Okay, so imagine you're working in a lab. A blood sample comes in, but it looks completely wrong. It's not red, it's not even the yellowish color of plasma, it's the color of dark chocolate. And this isn't science fiction. This is the real-life medical mystery of the chocolate-colored plasma.
And get a look at this. What you're seeing in that vial, it's not a cup of coffee, it's not a soda. That is a real patient's plasma. You know, the liquid part of our blood that's supposed to be a nice pale yellow. But this is a deep, dark, murky brown. Clearly something has gone profoundly wrong here.
So the question buzzing around the emergency room was the exact same one we're asking right now. What on earth could possibly make a person's plasma turn that color? Our story kicks off right where so many medical dramas do, in the organized chaos of a hospital's emergency department. So a 37-year-old woman comes in, and she is in a world of hurt. We're talking intense pain in her abdomen and back, plus nausea. It's just debilitating. Her doctors figure it's probably a flare-up of a condition they already know she has. And that condition is called acute intermittent porphyria, or AIP for short. It's a rare genetic disorder, and basically it messes up the body's internal factory for producing a really important molecule called heme. You need heme for your red blood cells to work right. When that production line goes haywire, it can trigger these absolutely excruciating attacks. But here's where the mystery really takes a bizarre turn. The lab's high-tech, automated machines, they run her blood work, and everything comes back normal. Green lights all around. The machines didn't flag a single error. They looked at this chocolate brown liquid and basically said, "Looks good to me." How is that even possible? So now the medical team is staring at a double-decker puzzle. The crazy color of the plasma and the fact that their machines were completely blind to it. So the investigation began, starting with the usual suspects. They went full-on detective mode, just a methodical process of elimination. First up, could it be hemolysis? That's when red blood cells rupture and spill their contents, which can darken plasma. Nope, tests ruled that out. Okay, what about suspect number 2, methemoglobinemia? That's another blood disorder that can cause a brownish color. Ruled that out too. All the usual culprits had an alibi. And this is the real turning point in the whole case. If a known disease process wasn't causing this alarming color, then what else was there? The answer was about to come from a place nobody expected. And the twist is just fantastic. Turns out, the answer wasn't in the patient's illness at all. The clue was hiding in the treatment for the illness. You see, to stop her severe AIP attack, the patient was given an IV infusion of a drug called hemin. Hemin is actually made from red blood cells, and it's the go-to, super effective treatment to shut down that faulty biochemical pathway that causes the porphyria attack in the first place. And that was the eureka moment. The dramatic, scary-looking brown color, it wasn't a symptom of her disease getting worse. It's a known, documented side effect of the hemomin infusion she had received just 6 hours before that blood draw. Just like that, the mystery was solved. I mean, this just lays it out perfectly. The thing that looked like a terrifying problem, the chocolate-colored plasma, was actually just evidence that the correct treatment was in her system and doing its job. The cure was the culprit behind the color. So the investigators had their theory locked in, but they also had the perfect way to prove it, beyond a shadow of a doubt. If the drug infusion caused the color, then the color should fade away as the patient's body naturally processed the drug. All they had to do was collect samples over time and watch. And that is exactly what happened. The sample taken just 6 hours after the infusion was the darkest brown. Fast forward to 24 hours, and you can see it's already getting lighter. By 48 hours, it's fading back to a murky yellow. And then, at the 72-hour mark, the plasma is almost completely back to its normal, healthy color. And here it is, the visual proof. You can't argue with this. On the left, the sample at its darkest, just 6 hours after treatment. On the right, the sample from 72 hours later. The evidence is just crystal clear. The symptom vanished right on schedule as the medication left her system. So what are the big lessons here? Well, first, that the most dramatic-looking sign isn't always a sign of disease. Second, And this is huge. The treatment itself can sometimes look like the problem. It's a powerful reminder for everyone in the medical field that you have to be aware of how treatments can interfere with lab tests and throw you for a loop. It really leaves you with a fascinating question to chew on, doesn't it? This case was about plasma color, sure, but it makes you wonder, what other so-called symptoms out there are actually just side effects hiding in plain sight? It's a great reminder to always ask, not just what's wrong with the patient, but also what have we done for the patient?